similar triangles are probably like one of the most common like problem solving strategies, techniques that you'll see in basically like any math competition. So like especially like the AMCs, similar triangles like appear like very often. Like they're probably like the most commonly tested geometry concept. So basically similar triangles, similarity is like very similar. Okay, so like similarity and congruence are like very like the terms are very like similar. No pun intended. Like if we say that two triangles are similar, we say that like the two triangles, they're kind of like scale factors of each other. So when we talked about congruent triangles, two congruent triangles were just basically triangles that had the exact same dimensions. Like the two triangles are basically the same triangle. Similar triangles, on the other hand, are triangles that look the same but have like different scale factors. So, for example, if I have a triangle like this, and I have like another triangle like this, we clearly can't say these two triangles are congruent, right? Because these two triangles clearly don't have the same side lengths. Like one is clearly bigger than the other. So we can't say the two triangles are congruent. But you can say they're similar because they kind of take on the same shape. Just notice that like this first triangle, if you were to like enlarge it, like make it larger, you would kind of get the second triangle. Like you kind of take the first triangle and you blow it up to get the second triangle. So that's what we mean by similar triangles, which is when two triangles like they kind of have like the same ratio of corresponding sides, but they're not like exactly the same. So now let's talk about like some ways to identify similar triangles. And just to briefly mention, like again, we don't have to have like similar triangles. It's possible you might see like similar quadrilaterals, similar pentagons, like similar any shapes basically, but we're talking about similar triangles because that's probably like 99% of what you'll see in geometry problems. Like similar triangles are much more frequent than other shapes. So let's first find a way to tell if two triangles are like similar. So the first and most common way to tell whether or not two triangles are similar is called AA similarity. AA similarity just stands for angle angle. And what AA similarity means is like if you have two triangles that look like this, and let's say you know two of the angles are the same. For example, let's say in the first triangle, you know there's an angle of 70 degrees, and we also know there's an angle of like 60 degrees, for example. And let's say in the second triangle, we also know there's a 70-degree angle and a 60-degree angle. Then we can say these two triangles are similar by AA similarity. AA similarity is probably the most important and most common like way you will be able to identify similar triangles, because you only need to find two angles that are the same in order to conclude they're similar. The next type of similarity we'll talk about is called SAS similarity. So this is similar to like the congruence, except it's slightly different. So SAS similarity, again, stands for side angle side. But this time the sides don't necessarily have to be equal as like they did in congruent triangles. Like if you had two triangles, and let's say we knew one of the angles, right? We knew one of the angles was like 80 degrees or something. And let's say we knew like the two side lengths of the first triangle. Let's say one of the side lengths was 3, and let's say the other side length was like 5 or something. Let's say the second triangle, we have that 80-degree angle, but let's say the sides have length like 6 and like 10, let's say. Then we can say these two triangles are similar because the ratio of corresponding sides are equal. So notice that we have this 6 and this 3. Like notice that 6 is like double 3, and we have 10 and we have 5. And notice that 10 is kind of like double 5. So the ratio of the corresponding sides, the ratio of 3 to 6 and 5 to 10, they have the same common ratio. So we can say that these two triangles are similar by SAS similarity, side angle side similarity. And the last way we can use to identify similar triangles is called SSS similarity. So SSS similarity is basically you use SSS similarity when you don't know anything about the angles of the triangle. So let's say you have two triangles and let's say the side lengths of one of the triangles is let's say 3, 5, and 6. Let's say this second triangle has sides of length 6, 10, and 12. Then we can conclude by SSS similarity that these two triangles are similar because if you were to take this first triangle and you were kind of to like scale it up, like double all the sides by 2, you can kind of like blow up the first triangle and to get the second triangle, right? Because you can change this 3 and double it to get the 6. You can change this 5 and double it to get the 10, and you can change the this 6 and double it to get this 12. So like the ratio of corresponding sides is the same, which means that the two triangles are similar. So that's how SSS similarity works.